Another way that a star can die out, like a neutron star, is known as a pulsar. So a pulsar is like a neutron star, but it's a bit weird in how it works. So the name pulsar comes from what's known as a semi-portmanteau. So although a pulsating radio source is its full name, it's commonly just shortened to pulsar. In other words, source is kind of tossed out. You can either say pulsating radio source or pulsar, but it's much easier and cooler to say pulsar. And what's actually weird is that these 2 points, sort of near the poles, or the magnetic poles of the star, actually release radio waves. So these are the same radio waves that you can listen to, Q102 to, or FM104, or any sort of radio station that you can think of. If you're an international viewer, any sort of radio source emits aptly named radio waves. So this pulsar can actually only be detected when these particular radio waves actually contact Earth and our equipment. So this pulsar is actually spinning incredibly fast. So again, more axial rotation stuff, but it's sort of spinning about the line which connects the 2 parts which are releasing the radio waves. So once this radio cluster actually comes into contact with Earth, we can find roughly where the pulsar is or how fast it's spinning. So you'll often see sort of pulsar data, so radio data sort of goes like this. Sort of these little bumps. And these bumps actually indicate the pulsar is facing our equipment. And this effect that these radio waves are inhibiting is known as the lighthouse effect. So if you've ever been near a lighthouse, for instance, where can I don't have to say something, but if you remember, if you've ever seen a lighthouse before, that inside of it, there's this light that actually spins around that has 2 beams. So there's a beam that looks like this, and then another beam like that. And these beams actually spin. And so it gives the illusion that it's like a space lighthouse, for instance, except instead of light, they're emitting radio waves. Now, although it might seem dangerous, radio waves are not actually that dangerous in comparison to other kinds of waves that we'll get onto. So things like gamma rays and UV and infrared. Radio waves are kind of weak in terms of their effect, but they're still dangerous in large amounts. But by the time the radio waves get to our equipment, they'll actually be reduced quite a bit because they might hit off space debris, for instance. So if a pulsar is emitting its radio waves towards us, it's not to be majorly concerned about.